but it's up to you if you want to do that. I don't, let's not do that for tonight. So let's move on to number 6. Is that okay?
Yeah.
Excellent. Now, one of the differences with number 6, I'll get that one snipped in here, is number 6 is not a square root, it's a cube root. It's got a power 3 there on it. So that's a little bit different, but your goal is always to isolate the root first, get it on one side of the equation. So what I mean by that is the subtraction by 10, we need to get rid of that.
Yeah.
So it's the cube root of x equals 3. Okay.
Mm-hmm.
All right, now from here we need to know how to undo a cube root. So I think we looked at this last time. It's really x to the 1/3 power.
Yes, we did.
Okay, so you undo it by raising it to the power of 3, because 1/3 times 3 is 1, and the goal is to get it down to x.
Mm-hmm.
So you cube both sides. So if it's a cube root, you undo it with a cube, power of 3. So you raise both sides to the power of 3, and x, because the cube root undoes the cube undoes the cube root, x becomes 3 cubed, which is 3 times 3 times 3, which is 27.
Yeah.
Any questions on that?
No.
Okay, let's look at another one here. Number 8. We should do another square root here in a moment, but for this one, the goal is to, again, it's to isolate the root. So like what I would tell a student, like let's say this was really unclear, but you treat like this is like a big X. It's like, what would you do to solve this equation for big X?
Yeah.
You would add 15 to both sides, right? And then you'd have this big X, 8 times big X equals 32. Divide by 8. So your big X is really 4. But big X is really this cube root of 10x.
Yeah.
Okay, so how do you undo a cube root?
Use cube it.
Cube it. So you cube both sides. Now, very importantly, it only undoes the root. So whatever's inside the root, that's what's left over. Doesn't matter what it is. It could be anything weird, but that's what's on. And then 4 times 4 times 4 is 64. And then you divide both sides by 10. So x equals 6.4.
Yeah, that's it.
And you might think, oh, well, that'll be tough to check. Well, when you put it back into the original, you're multiplying by 10. So 10 times 6.4 is 64. Cube root of 64 you can do. So you can definitely check these with reason.
Yeah.
All right. Yeah, so let's look at 10. 10 is a good one to look at. All right, so our goal again is to isolate the root.
Yeah.
Okay, so we're gonna add 2/3 to both sides. Now, maybe in a previous lesson, or maybe you've always in the past you would get rid of fractions. Sometimes you do that, sometimes you don't. This is a time I would wait to like try to multiply by 3 to get rid of the fraction. I would just move it over to the other side.
Yeah.
All right, so now the next thing we've got here is to undo the square root. So you undo the square root with a square.
Yeah.
So on the left, it undoes the square root, so it becomes 2x.
Yeah.
On the right, whenever you have an exponent to a top and a bottom, you apply it to the top and the bottom. So this is 2 squared over 3 squared.
Yeah. So then you square each individual one, right?
Yes. So you square each of the numbers, and that's always the case with a fraction. So it becomes 4 over 9. But we're not quite done.
divide by 2.
Yeah, divide by 2. Now this is where you need a little bit of a reminder how to do this. A couple of ways to do it. This 2 actually ends up going down onto the bottom, but you can also multiply by the reciprocal. 2's reciprocal is really 1/2. Becomes 4/18. They both reduce to by 2. You divide them both by 2 to get 2/9.
Yeah.
Any questions on that?
No, I think I got that.
Okay. So those are the nice ones. You would love those on a test or quiz. You probably will not get those though.
Yeah.
All right. So is it okay if I go to 16? 16, okay?
Yeah, that's good.
And is my am I coming in clear, loud and clear?
Yes, you're good.
Okay. All right. So the goal is actually the same in this next grouping of problems. It still is to isolate the root.
Yeah.
Okay. Now, before we do that though, do you remember what the graph of a square root looks like?
I think I have it written down, but not off the top of my
Okay,
head.
so it's something like I've drawn here to the right. How about on the left here? Do you have any idea what x minus 10 looks like as a graph? Could you describe it with one word, or tell me what it is in what is one word?
It would be, well, negative. It'd
A
be
line.
going.
A line. So it's a line, right? It's got a slope of 1, but it's a line.
Okay.
So the reason I'm asking you, saying that is because it could be that the line and the thing intersect once. It could be that they actually intersect twice. And it could be actually that they never intersect.
Yeah.
So this is where we're getting into like possible, they call them extraneous solutions. Maybe you heard that term in class.
Yes. Yeah, we have.
Okay. Now, so, but the goal is to isolate the root. We've done that, check. Okay. The root is on one side of the equation or the other. Very, very pleased with that.
Mhm.
Now, there's only one square root in this problem. You'll see later on that there's more than one square root potentially, but you undo the square root with a square on both sides of the equation.
Yeah.
So on the right side, you're like, yeah, I got it. 9x, no big deal. On the left side, you have to remember to write it out as a binomial, 2 binomials, and use FOIL.
Yeah.
All right, so this becomes x squared minus 20x plus 100 equals 9x. If you have questions on FOIL, please let me know. We're going to probably do a few of them tonight,
Yeah.
but we've done them in previous lessons as well. Okay, so now your goal is to get all terms on one side of the equation.
Mhm.
So I'm going to subtract 9x. So that gives you x squared minus 29x plus 100 equals 0.
Yeah.
All right. And so this on the left, it's solved a number of ways. The first approach you always try is factoring. Okay, so you're looking for two numbers that multiply to 100. Okay, but then they add to minus 29. This is usually the hardest part for students because you've done all this other work and now it's like, oh, I got to factor. It's like, yeah, you got to factor. You got to come up with that.
I think it, so I think it'd be -25 and -4.
Perfect. Yeah. Very good. So you set each of those equal to 0. And you get two answers, x equals 25 and x equals 4. But the question is, do they both work? So that's where you really do have to go back to the original and try them.
Yeah.
Okay. And the way you try them is you're not solving anymore. It's like you're really asking, does the left side Does the left look like the right? So when we try 25, is 25 minus 10 the same as the square root of 9 times 25? So on the
No.
left, so on the left
Uh,
it's 15, but on the right it's the square root of 225, which is 15. These match. This one's good. But then what about for 4? Okay, so you try 4. 4 minus 10, does that equal the square root of 9 times 4? Minus 6, is that equal to the square root of 36? No.
yeah.
So is it the case that there's always one that works and one doesn't? Most of the time you see that in your problems, but it could be that they both work. That's why you check.
Yeah.
But it's usually when you get 2 answers that you start worrying about this. We're obviously going to do more, but any questions on that or any concerns before we move forward?
No, I think I'm good.
Okay, fantastic. So number 18 we'll look at next. Number 18 here. So again, you want to isolate the root, and you've already done that. On the left, it's already isolated. So you feel good. You're like, okay, I know what to do. I'm going to square both sides. On the left side, it just undoes the root. The right side, I always recommend writing it out as a multiplication of binomials.
Yeah.
Can you FOIL that for me on the right, please?
Yes. So it's going to be x squared plus 3x plus 3x. So you can combine those. So that'd be 6x. And then plus 9. I think you're on mute. I don't know if you're trying to talk or not.
Yeah, sorry, apologies. Yes, you're going to get one of these on your test, and hopefully it's not too bad. So now you want to get all the terms on one side or the other. So I would move everything to the right because we really want x squared to be positive.
Yeah.
That's the preference. Then you can move that 0 over to the right side rather than on the left. That's okay.
So now you factor it.
Yeah, factor. And the ones you're going to get on your test are likely factorable. So if you can't factor it, you've either made a mistake or you can't find the right factors. Just look back for
So it'd be 7 and -3.
yeah, x plus 7, x minus 3. Very good. Set them both equal to 0. 2 answers. Okay. All right, so we're going to check these. I'd like you to check the -7.
Okay. So -7 does not check.
It does not work, right? You get 4
Yeah.
does not equal -4. Yeah.
Yeah.
Okay. And you'll find that the 3 does work. 2 times 3 plus 30. Does that equal 3 plus 3? Square root of 36. Okay. So that one does work. So here's the thing though. Your instructor is expecting you to have both answers listed just like we did and show the check, but then you're supposed to like cross out one of them and somehow indicate that the other one is correct also.
Yeah.
Okay. Now here's another statement that's important is just because it's negative does not mean it's excluded. Likely it is, but math's full of exceptions. You really want to check them both and then decide. Don't just say, oh, that one's out because it's negative.
Right.
Okay. Can we move to, I want to skip 20. That's okay. I'd like to go to 22, 21, 22, or 23. Is that okay? Or do you have
Yeah.
to okay. So let me do 22. This is the next kind of variation on the same problem. And in some ways, it's actually better, as you'll see here in a moment. So in like every problem I've written down today, I've said isolate the root, right? You've seen me write that a number of times today.
Right. Yeah.
But you're like, well, Matthew, there's two roots now. Okay. Yeah, so this is the variation. So we're going to move this negative one to the right.
Yeah.
So it becomes square root 3x minus 3 equals square root x plus 12. Okay. So you cannot actually isolate the root in this problem. You have roots on both sides, but that's actually okay. Roots on both sides. Because when you square both sides, what happens to the roots?
It cancels out.
Yeah, they cancel out. So you're going to actually square both sides. 3x minus 3 equals x plus 12. And then you just solve it the way you've done these types of equations, in previous years. You get your x by itself, move things around here. So 2x equals 15. Can't believe they didn't give you one that was nice. X equals 15 over 2. Okay. Now this one's harder to check. Is that really right? Yeah, I guess it is. Huh. So to check this, you're gonna not like this. I mean, you got it, but you really are supposed to check.
Yeah.
So it's square root 3 times 15 over 2 minus 3 minus square root 15 over 2 plus 12. Now, remember, I'm going back to the original. You always check in the original, not the one where you move things around.
Yeah.
All right. Okay, so what to do here? So 3 times 15 over 2, that's 45 over 2. 3 over 1, if we change that to bottom of 2, you multiply the top and bottom by 2, so that's 6. So you end up getting 39 over 2 square root there. And you'll see why we're leaving it this way in a moment. 15 over 2 plus 12. 12 as a fraction is 12 over 1. So that's 15 over 2. Multiply the top and bottom by 2 to get that common denominator. So this is 39 over 2 again. So the question for you is do we actually need to calculate these, or can we just say, hey, it's the same thing. It's the square root of something minus the square root of something. They're exactly the same. That equals 0. Is that okay?
Yeah.
Yes. All right, let's look at a 23 next before we go to, we're gonna have to do a 25 or well, I guess we'll do 25 for sure. That's the classic exam question.
Yeah.
Okay, so for 23 here, it's just like the previous problem in that you want to isolate the roots, meaning you get one on each side. So what I used to do, oh, are you still there?
Yes.
Okay, I just heard someone enter. I'd leave the room. Okay, so what I do is I just move the equal sign right there in the middle. Because when you add it to the other side, you get the first one equals the second one. Okay, but if you want to
Yeah.
add it, you want to add it, you can. There's a little bit of a shortcut there. Now you're going to cube both sides. Why am I cubing here instead of squaring?
Because there's a cube in front of it.
Cube root, yeah. So you undo a cube root with a cube. You got to show your steps. They're looking for that. Right. So this time I'm going to move the 2x right. on that. So we got -6 equals 6x. Divide both sides by 6, and x equals -1. We talked about odd versus even roots last time, I think. And
Yeah.
for odd ones, the negatives are always okay. It's only the even ones where you've got to be, a little bit unsure here. So let's do a quick check on this one. All right, so you gotta try that. Number 2 times -1 minus 5, cube root of that, minus cube root of 8 times -1 plus 1. Okay, so the one on the left here becomes the cube root of -7. The one on the right is also the cube root of -7. We don't need to know what it is. We just need to know that they are the same. And so, yes, it works.
Yeah.
I probably say this every lesson, but there's nothing interesting here. You're never going to use these again. These are just math problems that
Right.
it's not a lot of applications to them. Okay, I'd like to do 25 because this is the classic kind of exam question that most students hope they don't get, but you do. What's different about this problem than the previous problems is this +1 right here. All right, and it is problematic. So you end up having, in these types of problems, you end up having to square twice. It's bad. It gets worse before it gets better. You've probably heard that many times in your life. This one does get worse before it gets better. All right, so on the right, though, it's just x plus 5. You would agree with that? You see that?
Yeah.
Okay, but on the left, this is what it is on the left. It's square root of 3x minus 8 plus 1 times the square root of 3x minus 8 plus 1. And you do have to FOIL this. Okay, now as a reminder, off to the side here, the square root of something times the square root of something equals the thing that's inside. So when you do your first times your first, and I'll even write this out because you may want to look back at this one. This ends up just being the thing that's under the square root for the f part. For the O, it's the square root of 3x minus 8 times +1. So it becomes plus square root 3x minus 8. For the I, it's just the different order, but it's 1 times the square root of 3x minus 8. Okay, and then the last is 1 times 1 plus 1. So for this middle one here, let me switch colors to illustrate this. This is like the square root of b plus the square root of b. That means you have 2 square root b's.
Right.
So it becomes +2 square root 3x minus 8 plus 1 equals x plus 5. What do you think about this now?
You.
Did it get worse though? That's what I'm really asking. Do you see how it got worse before it
Yeah.
Okay. So from here, you're like, what do I do now? Well, the goal is actually to isolate the root again, because there's only one root now. There were two, but now there's just one. So it's actually, you're getting on the right track here. So you've got to subtract 1 from both sides, subtract 3x, and add 8. So that gets you 2 square root 3x minus 8. So you basically undo all the stuff that's not part of the root. Minus 2x plus 12, like that. Let me know when you get caught up to this step.
Yeah. Okay, good.
So I hate I'm overloading you too much information, but I have to say this here. When the number out in front goes into both of these numbers on the right, you want to divide. Like, do you see how both of these numbers on the right are divisible by 2? Minus
Yeah.
2x. So that's when you want to clear out this number first. If they're not divisible by 2, which could happen, then you wait to do that. But that's a different problem we're not seeing. Okay, so this is minus x plus 6. And from here, you square both sides. And you're like, wait, more? Yeah, there's more. 3x minus 8 on the left. And then to FOIL this, I'm going to just switch the order. 6 minus x, 6 minus x. You get 36 minus 6x plus x squared. So now it kind of looks like one we've already been doing. Add 8 to both sides, subtract 3x. X squared minus 15x plus 44 equals 0. So it ends up, believe it or not, working out like this to x equals 11 and x equals 4. And you still have to check.
Right.
Okay. And I think they actually both work. Just kind of my scan here of this. So like when x is 11, it's the square root of 3 times 11 minus 8 plus 1. Square root of 11 plus 5. So 33 minus 8 is 25. So square root of 25 plus 1 equals square root of 16. 5 plus 1. Oh, see, that one does not work. 6 does not equal 4.
Yeah, so then 11's wrong.
Yeah. Although it had all the appearances of probably working out. So this one's 2 plus 1. So the one on the right does work.
Yeah.
Now, these almost always work out nicely in terms of the numbers. So if you get fractions or decimals or something that's really odd, you should question where you missed a step. These are tough. These are lots of work to do. Okay, and I can't remember which numbers you said in 27 through 34 that you needed to do. Was it odds, evens?
Let me see. So it's 27 through 32, and it's all of them.
All of them.
And then
Okay.
it's 37 through 41 all.
So I don't have anything past 36. So if you want to send over another picture, please do that. But yeah, I'll do, I guess I'll do the odds since you don't have those.
Yeah.
Or I'm sorry, the evens since you don't have those. But, or we can do, I mean, we can do them all. It's up to you.
Or I also have them written down if I can just tell you the answers.
Okay. So let's look at 28 here. I don't want to say this, like another way that this thing could be written that I've circled x to the 3/2 power, if you remember, is the square root of x cubed, like that. Because the number on the bottom, like the square root of x, there's really a 1 there and a 2 there. That's x to the 1/2 power. That's how I remember it.
Yeah.
Like that. And I've been saying this, over and over again, you isolate the root. Well, you isolate the power, the variable to the power. Like that's the same thing as root. So you need to divide by 4. So it's the square root of x cubed equals 8.
So then you cube both sides.
And you want to get rid of the square root first. The cube is
here. Right.
Yeah, so that's why I think doing it this way helps, because you see the order. So x cubed equals 64. And it's you got to be able to recognize, oh yeah, 64, it's not just 8 squared, even though that is true. It's not just 4 cubed. It's also 2 to the power of 6. Like there's a couple of options for it. And you really want to know all 3 of those depending on the scenario.
Yeah.
So in this case, x would equal 4. Like there really is no work between these two lines, because you can just remember the number or work it out. 4 times 4 times 4. Few options there like that.
Yeah. Okay.
So maybe we should do 27 to just because it's simple enough that we're redoing we're doing the other type of power, which is the where it's an odd power and then a root. So,
Yeah.
okay, so again, it's x to the 2/3. That's the cube root of x squared. And that's got to be very, very clear for you. You got to be like, oh yeah, I can do that. No big deal.
Yeah.
Okay, now divide by 2. Okay, so you got cube root of x squared equals 4. Okay, so now you undo the cube root. Whatever's on the outside, you undo first. That's why I do it this way rather than try to undo the power, because I think it's clearer to undo the root in this step first.
Yeah.
All right, so you undo that by cubing both sides. So x squared equals 64. So it's very easy at this step to forget that there are 2 solutions. Because when you take a square root of both sides, it's plus or minus the square root of 64.
Right.
And that's the most common mistake here, to do all this work and then misremember that there are 2 solutions. So when you have, you go back here, when you have an even number in the numerator, there are either 0 or 2 solutions typically.
Yeah.
But when it's an odd number in the numerator, there's 1 solution.
Yeah.
And I don't really like remembering rules like this, but if it helps you, that's fine with me. Whatever's going to get you the best grade on this thing when you take the test or quiz.
Yeah.
Okay. You said 37 through 40. Could you give me one in that grouping to look at just to see?
Yeah. It's like inequalities, but it's basically the exact same thing. So
Okay. Yeah, go ahead and give me one because this is important for us to
it
do.
says 2, and then it says cube root of x.
Like this?
Yeah. Minus 5 is greater than or equal to 3.
Like this?
Mhm.
Okay, very good. So again, our goal is to isolate the root
Yeah.
over and over again. So we're gonna add 5 to both sides. 2 cube root x greater than or equal to 8. Always isolate the root, and then you divide by 2. So you have cube root of x greater than or equal to 4. All right. So if the first time you learned about inequalities in algebra 1 or pre-algebra, you actually may have been shown that you just solved the equality problem.
Mhm.
Okay, and it's the same thing here. You actually just want to solve it as if it's an equality problem. Cube both sides. X is ends up being equal to 64. Okay. Now 64 is what's called this break point. I like that terminology. It may not be exactly what you're in the classroom, but it's the breaking point between it either being greater than or less than, because it's right there, it's equal to. Okay. And what's hard for you as a student is to know, well, which side do I shade? Is it the right side or the left side? Like do numbers bigger than this work, or do numbers smaller than this work?
Yeah.
Okay, so you create what are called test points, but you choose test points that like you can take the cube root of, like, say 8.
Yeah.
And so if we go back to the inequality, is the cube root of 8 greater than or equal to 4? Is that true or false? So the cube root of 8 is 2. Is 2 greater than or equal to 4?
No.
No, so this does not work. You could say no. Now, where it gets harder is like, what's a number bigger than 64? But like 125, it does not have to be very close. And the cube root of 125 is 5. Is 5 greater than or equal to 4?
Yes.
Yes, so that works.
Mm-hmm.
So what we're showing is that anything to the right of 64 works, anything to the left of 64 does not. So your solution, your answer is all the numbers bigger than 64, x greater than or equal to 64. Now you get that from the original inequality, but there may be some problems where you have to flip, or there might be some other things. So the more general approach is to make this number line and test points on either side.
Yeah.
And see if it works.
Yeah.
Do you have another inequality that we can look at maybe, or from that section? Or that,
Yes, there is. It says the cubed root of x minus 4
Okay.
Is less than or equal to 5.
Yeah, very good. So yeah, if that's why I don't have the full picture, but this one I would just solve the same way as the others. Meaning like, don't even worry about the fact that it's an inequality. Like you're going to cube both sides. So you get x minus 4 less than or equal to 125. And then you're going to add 4 to both sides. So x is less than or equal to 129. And you don't need to do any of that testing that I just mentioned. It's just, if you get a more complicated problem, you will want to do something like that.
Yeah. There is one more equality. That's the last one.
Yeah, whenever you're ready.
It's 4 and then the square root of x minus 2.
Like this?
Is greater than 20.
Like this?
Uh-huh.
Okay, fantastic. All right. Yeah, so this one again, you just treat it the same as we've been doing here. You just solve for x without even worrying about the inequality. So you divide by 4, square root x minus 2 greater than 5. You square both sides. So you get x minus 2 greater than 25. Add 2, x greater than 27.
Yeah. Yeah, I think this whole like unit is making sense to me. I feel like it's kind of straightforward.
That's good to hear. A couple minutes left here. Do you want us to, I guess we could do 29 or 30 if you'd like.
Yeah. Even yeah, that seems good.
Yeah, let me see here. I guess I'll just keep it simple. I'll do 29. All right, so again, your goal is to isolate the root. So this is really the 4th root of x on the right. Okay. Plus 3 equals 0. So you subtract that 3 from both sides and you get the 4th root of x equals -3. And you might think from here, like, okay, I got it. I'm gonna, fourth or power 4 both sides. Okay, so you end up getting x equals, and -3 times -3 times -3 times -3 ends up being 81. And you feel really good about your answer, but there's a problem. Okay, and the problem is actually in this line right here. You had the 4th root of x equals a -3. Okay, there is no solution to this because the 4th root of a number can never equal a negative, and it comes from the graph of a square root or a 4th root. It never hits this number down here.
Yeah.
So you know how would you know? Well, you'd go back and you'd check it. So you really do need to check all your answers, because you'd get, okay, it's the 4th root of 81 plus 3. 4th root of 81, I got it, that's 3 plus 3. But is that 0? No. So if you check your answers, you will walk out of the test or quiz knowing, hey, I got everything right, or hey, I did not get everything. I'm not sure because I didn't check.
Yeah.
All right, now I know I did a lot of talking at you today. I hope you understood. I mean, I've obviously would like to get a little more of you involved, but please review the notes, please look at the video, and happy to help you again if needed.
Thank you so much.
Yeah,
I
you're
think I
welcome.
have one scheduled for Wednesday, so
Oh, that's
thank you
right.
for
Yeah,
that.
awesome. I'll see you then. Hope you have a
Yeah.
great couple of days.
Thank you, you
Okay,
too.
bye now.
Bye.